Math 2. This is a continuation of our unit circle notes from last week. Let's go around our unit circle, putting in all of our degrees. So for starters, let's put in our increments at 30. So we begin at 0 degrees and we have 30 degrees. Skip the 45. Now we add 30 and get 60, add 30 and get 90, add 30 and get 120, skip my 45 degree angle and add 30 and we get 150 degrees, add 30 we get 180, add 30 we get 210 degrees, skip my 45 degree angle, adding 30 you get 240 degrees, adding another 30 you get 270, adding another 30 you get 300, skip your 45, adding another 30 you get 330 degrees, and finally you've gone all the way around with 360 degrees. We did leave off our 45 degree increments, so let's go back. 45 degrees plus another 45 is 90, plus another 45 is 135 degrees, plus another 45 is our 180, plus another 45 is our 225 degrees, plus another 45 would be 270, and plus another 45 would be our 315 degrees. And our last 45 brings us back to 360 degrees. So I'm going to use the same thinking to write radians on my unit circle. Most of the time when you're studying the unit circle, you will have a unit circle quiz. It will be a blank unit circle that you have to fill in from memory. Being that we're online, you will not be getting that unit circle quiz. But let's talk about a couple ways to fill in the radians from memory. So one of the ways to fill in radians from memory is to memorize that 30 degrees is pi over 6 radians, or be able to calculate it with your conversion, and to memorize that 45 degrees is pi over 4 radians. If you memorize those two, or if you convert those two, you can fill in the entire unit circle. So I'm going to actually write on the outside of my unit circle because this is the work I'm doing in my head. But if I think about this, I'm going to go around in 30 degree increments. So this is my 1 pi over 6. If I add another 30 degrees and another pi over 6 radians, I'm at 2 pi over 6. If I add another 30 degrees, or pi over 6 radians, I'm now at 3 pi over 6. Let's continue going around in 30 degree increments. I'm now at 4 pi over 6. Skip your 45 degree angle, and I'm now at 5 pi over 6. Going another 30 degrees, I'm at 6 pi over 6. Another 30 degrees, I'm at 7 pi over 6. Another 30 degrees, I'm at 8 pi over 6. Notice I skipped over my 45 degree. Another 30 degrees, I'm at 9 pi over 6. Another 30 degrees, I'm at 10 pi over 6. Another 30 degrees, skipping my 45, I'm at 11 pi over 6. And finally, my last 30 degrees, adding my last pi over 6, I'm at 12 pi over 6. So now I'm going to write the equivalent radian on my unit circle, meaning I usually have to reduce. So 2 pi over 6 does reduce by 2 to pi over 3. And then 3 pi over 6 reduces by 3 to pi over 2. 4 pi over 6 reduces by 2 to 2 pi over 3. 5 pi over 6 does not reduce, so this is 5 pi over 6. 6 pi over 6 reduces by 6 to pi. 7 pi over 6 does not reduce, so I'm just going to write it. 8 pi over 6 reduces by 2 to 4 pi over 3. 9 pi over 6 reduces by 3 to 3 pi over 2. And 11 pi, I skipped 10 pi over 6, that should have a pi there, reduces by 2 to 5 pi over 3. And then 11 pi over 6 does not reduce. And finally, 12 pi over 6 reduces to 2 pi. And I forgot to put my 0 radians for when I started. So I'm going to erase this work out to the side because I'm going to put a lot of things on my unit circle, and I want it to be as least confusing as possible. So that was all of my 30 degree increments, my increments of pi over 6 units. So now let's go and do my 45 degree angles. So remember, this is 1 pi over 4. So if I go another 45 degrees, I'm at 2 pi over 4. If I go another 45 degrees, I'm at 3 pi over 4. Another 45 degrees, I'm at 4 pi over 4. Another 45 degrees, I'm at 5 pi over 4. And then 6 pi over 4. And then I'm at 7 pi over 4. And I end at 8 pi over 4. So now, just like last time, I go through and reduce where I can. Well, 2 pi over 4 is already on my unit circle. It does reduce, it's pi over 2. 3 pi over 4 does not reduce, so I'm going to write 3 pi over 4 on my circle. 4 pi over 4 reduces by 4 to pi, but it's already there. 5 pi over 4 is next, and it does not reduce. 6 pi over 4 reduces to 3 pi over 2, and it's on my unit circle. And 7 pi over 4 does not reduce, and it's on my unit circle. And 8 pi over 4 reduces to 2 pi, which is already on my circle. So I'm going to erase this out to the side, and I've now filled in my unit circle with all of my radians. There's quite a few tricks to that. So in the future in your math course, if you're going to have a blank unit circle quiz, there's a lot of tricks on YouTube, for instance, that will help you fill in those radians very quickly. So let's talk about how to get the coordinates around the outside. So first of all, let's do our quadrantal angles. In a unit circle, specifically my radius in a unit circle is equal to 1 unit. So I know from the origin to this coordinate right here on the x-axis is 1 unit. 1 unit in the x direction. I haven't gone up or down at all. Think about this as now, instead of a circle, think about it as an xy grid of coordinates. And so then from the origin up to my 90-degree angle, it would be 1 unit up on the y-axis and 0 units in the x direction. Pi then would be 1 unit in the x direction, but it's negative. So this is a -1, 0 in the y direction. And finally, 270 degrees is down the y-axis 1 unit because its radius is equal to 1. So this would be -1 in the y direction and 0 units in the x direction. The next thing I want to point out as we go around is that I'm going to use triangles to fill in the rest of my coordinates. So it's really interesting that the unit circle is actually made up of our special right triangles from earlier this year. I'd like to point out the 30, 60, 90-degree angles at the top of the page and the 45, 45, 90. So I want to first point out that these are the triangles that we used when we studied special right triangles. However, notice the hypotenuse. The hypotenuse on all 3 of these is 2. My radius of my unit circle will be the hypotenuse, and it's equal to 1. So I'm going to take a moment before we get started, and I'm going to divide all the sides by 2 so that my hypotenuse is 1. I'm going to divide all the sides by 2 so that my hypotenuse is 1. And lastly, I'm going to divide all 3 sides by 2 so that my hypotenuse is 1. So now I'm going to use these triangles. So first, let's use the 30-degree angle. So this is my 30-degree angle on my unit circle. And so let's shade this in with my light pink. And let's transfer this light pink triangle to my unit circle. So this is my 30-degree angle, and I'm putting my 30, 60, 90 triangle into my unit circle. And so this is my 30-degree angle, this is my 90, this is my 60, and I know those distances. My radius is 1, my hypotenuse is also 1, my long side is rad 3 over 2 units, so the distance in the x direction is rad 3 over 2 units. So let's put that in for my x coordinate, rad 3 over 2 units, and my short side is 1/2 after I've divided by 2. So my short side here is 1/2 units up, and that is the coordinate at my 30-degree angle. So let's take a look at the 45-degree triangle. I'm going to shade this triangle in light blue, and I'm going to transfer this 45, 45, 90 triangle to my unit circle. So I'm going to drop a straight line down to my x-axis, and I'm going to shade this in. And this is my 45, 45, 90 triangle on top of my unit circle. So I know that my hypotenuse is equal to 1, And I happen to know that each of my sides is rad 2 over 2 units. So I'm over rad 2 over 2 units in the x direction to get to this point, and I'm up another rad 2 over 2 units in the y direction to get to that point. So let's take a look at that with my last triangle, the 30, 60, 90 triangle. So let's shade this in yellow, and I'm going to transfer this triangle to my unit circle. So I'm putting my 60-degree angle at the origin, and I'm dropping a perpendicular down to my x-axis to create my 90-degree angle. And there's my yellow triangle transferred to my unit circle. And I know my short side is 1/2 after I divided all three sides by 2. So I'm over 1/2 units in the x direction, and I'm up rad 3 over 2 units in the y direction. And those are my 3 coordinates in the first quadrant. And I can use them now by doing simple reflection to get all the other coordinates on my unit circle. Keep in mind in the first quadrant, both your x and your y coordinates are positive because x and y are positive in the first quadrant. When I go to fill in my second quadrant, keep in mind all your x values are negative because this is the negative x-axis, and all of your y values, since you're going up, all of your y values are positive. In the third quadrant, both my x and my y coordinates are negative. And finally, in the fourth quadrant, my x coordinates are positive because this is the positive x-axis, but all of my y values are negative in the fourth quadrant. So in order to use reflection, I'm going to reflect this point, not trying to put too many things, but I'm going to reflect that point over. It's the same x distance and y distance on the being reflected on the other side of the y-axis. So then this would be negative 1/2 units over in the x direction, and I'm still up rad 3 over 2 units in the y direction. I'm next going to reflect my other points over the y-axis. So when I do that, this becomes negative rad 2 over 2 units in the x direction and rad 2 over 2 units in the y direction. And finally, I'm going to reflect my third point over my y-axis. And so I know that this is negative rad 3 over 2 units in the x direction and up a positive 1/2 unit in the y direction. And I can do the third quadrant by simply reflecting those coordinates down. So now I'm going to visually reflect this coordinate down below the x-axis. When I do that, my coordinate is now negative rad 3 over 2 units in the x direction, and I'm down a 1/2 unit under the origin in the y direction. I can reflect down my 45-degree angle. And when I do that, I'm at negative rad 2 over 2 in the x direction, and I'm also down negative rad 2 over 2 in the y direction. And finally, for my last coordinate, I'm going to reflect this point across my x-axis. And when I do that, it's negative 1/2 units in the x direction, and I'm down negative rad 3 over 2 units in the y direction. And you can get your fourth quadrant either by reflecting your third quadrant over the y-axis or your first quadrant over the x-axis. But when you do, you're going to get a positive 1/2 negative rad 3 over 2 in the y direction for your 300-degree angle. For 315 degrees, you'll be positive rad 2 over 2 in the x direction and negative rad 2 over 2 in the y direction. And for your 330-degree angle, you are positive rad 3 over 2 in the x direction, and you are negative 1/2 in the y direction. And these are your coordinates all around the unit circle. We use these coordinates to do trig without using the calculator. So looking at some examples of that are down here below. I'm going to make my notes a little smaller so this fits. Sorry, arranging these. Okay, so going back to class a while ago when we were learning trigonometry, if you have a right triangle and you have theta, we have our side opposite, we have our side adjacent, and we have our hypotenuse. And we learned that our trig functions, sine, cosine, tangent, followed our SOHCAHTOA acronym. So sine of theta, cosine of theta, and tangent of theta can be thought of as the sides opposite, adjacent, and hypotenuse. Using the pink, blue, and yellow triangle above, my adjacent side was my x coordinate. That was the distance I traveled along the x-axis. My opposite side was where I got my y coordinate. That's how far up or down the y-axis I traveled to get to my point. And in all of these, my hypotenuse was equal to 1. So if sine is opposite over hypotenuse, looking at the triangle, opposite is y and my hypotenuse is 1. So sine theta is going to be equal to my y coordinate. Cosine theta is adjacent over hypotenuse. So the adjacent is my x and my hypotenuse is 1. So cosine theta is going to conveniently be equal to my x coordinate. And tangent is opposite over adjacent. So that would be my y coordinate divided by my x coordinate. So how do we use the unit circle to do trig? So we find exact values of sine, cosine, and tangent problems using the unit circle. In other words, not our calculator. And usually unit circle quiz or a unit circle test is non-calculator. So, for example, sine of pi over 2, you have to go locate the coordinate at pi over 2. If you look up above, that coordinate was 0, 1. And so now you look to see if you're doing sine, cosine, or tangent. In this case, I'm doing sine, and I know sine is equal to my y value. So the sine of pi over 2, I would simply write a 1. I'd be done. It's my y coordinate. For example, if that had been cosine of pi over 2, I would have simply wrote a 0. It would have been the x coordinate. I would have been done. And if this had been tangent of pi over 2, remember that's listed above as y over x. That would have been 1 over 0. And anytime you divide by 0, that is undefined. So this is how I can use my coordinate to get exact trig functions. Let's take a look at cosine of pi. So go look at the coordinate at pi. It's negative 1, 0. If I could get my highlighter. So the coordinate is negative 1, 0. And so cosine is my x coordinate. So this answer is simply negative 1. Sine of pi over 6. So again, go look for your 7. Oh, sorry. I think I was supposed to say 7 pi over 6. So go find your 7 pi over 6 angle. Oh, I was supposed to be using my yellow highlighter. So when you look at your coordinate for 7 pi over 6, you're doing the sine, which is my y value. You're simply going to write down negative 1/2. Done. Sine of 300. So again, you're going to go look for your 300-degree angle. You're going to go examine what your coordinate is. And sine is equal to my y value. So you're going to write down the y value, which is negative rad 3 over 2. Finally, tangent. So when I do tangent, I usually have to do a little bit of simplifying. So let's take a look at tangent of negative 120. First of all, it's negative. So let's go counterclockwise. The tangent of negative 120. Negative 120 is actually here at basically positive 240 degrees or coterminal with negative 120. So my coordinate is negative 1/2, negative rad 3 over 2. So tangent is y divided by x. So in this case, tangent would be, let me change this to my black pencil. So this would be negative, my y value, negative rad 3 over 2 divided by 1/2, negative 1/2. And so the negatives cancel. And if you remember from junior high, when we're dividing fractions, we multiply by the reciprocal. So this would be rad 3 over 2 times the reciprocal of 1/2, which is 2 over 1. And so the 2's cancel, and I simply get rad 3 over 1, which is rad 3. And so the tangent of negative 120 is simply rad 3. Sometimes when you do these problems, you have to rationalize the denominator. Let's take a look at an example of that real quick. So let's say our problem asks for the tangent, and I'm going to write in this top area up here. Let's say it asks for the tangent of, we'll say 5 pi over 6. So the tangent of 5 pi over 6, so the coordinate, if I could get my highlighter, the coordinate is over here. It's negative rad 3 over 2, comma 1/2. So if I'm doing tangent is y over x. I'm looking at the box below. So my y coordinate is 1/2 divided by negative rad 3 over 2. So remember, when I divide my fractions, it's the same thing as multiplying by the reciprocal. This becomes 1/2 times, the reciprocal would then be negative 2 over rad 3. So now my 2's cancel, and on top I have negative 1 times 1, which is negative 1. And on the bottom I have 1 times rad 3, or 1 over rad 3. In mathematics, that's not considered simplified because it has a radical in the denominator. So I'm going to multiply the top and the bottom by the square root of 3. I do that because when I multiply the top, I get negative rad 3. But when I multiply the bottom, rad 3 times rad 3 is really the square root of 9, rad 9, and that is 3. This answer and negative 1 over the square root of 3 are actually the same. But in mathematics, we consider negative rad 3 over 3 to be more simplified, very similar to the idea of 2/4 versus 1/2. They're the same, they're equivalent, but 1/2 is considered simplified. So that might come up in your practice. Thank you very much.